These next ones that we're going to be looking at, if we're combining a mixture of two different salt solutions. So be on the lookout for those key words. If they tell you something's a solution, then that means it's been dissolved in water, right? It's aqueous. Don't have to worry about your solubility rules if they tell you right in the problem itself that something's a solution. So these problems we're looking at, you're mixing two aqueous solutions together. These guys are known as double displacement or double replacement, depending on the textbook you look at, depending on who your chemistry teacher is. Both terms are normal. For these problems, you got to know your solubility rules in order to be successful at these problems. So something like this, solutions of calcium nitrate and sodium sulfate. Well, calcium nitrate, it tells you right in the problem that it's a solution. It's been dissolved in water. So we would break that up into calcium ions and nitrate ions. Well, calcium's +2, nitrate's -1. So that calcium would have 2 nitrates along with it. We would react that with sodium sulfate. So it's a solution of sodium sulfate. So sodium ions, Na+1, sulfate ions, SO4 -2. When you combine +1, -2, you're going to need 2 sodium ions to balance out the charges there. Well, your calcium goes with sulfate and the sodium goes with nitrate. Sodium nitrate is soluble. So on the product side of the reaction, we would show the sodium and nitrate ions broken up, just like they are on the reactant side. So these guys are going to end up being spectators. The calcium and the sulfate, however, they combine to form calcium sulfate, which is insoluble. It does not dissolve in water, and so we show it together like this as a product. If we had something like part B, a solution of silver nitrate. So solutions telling you break up that guy into silver ions and nitrate ions. +1, -1. If we mixed that with a solution of potassium iodide, so again, solution, soluble, break it up. K+1, I -1. That silver is going to go with that iodide. The potassium is going to go with the nitrate. So if you know your solubility rules, you'll know that anything with an alkali ion in it, lithium, sodium, potassium, rubidium, cesium, all those guys, always soluble. Nitrates, always soluble. So if we were to put potassium and nitrate together, they would dissolve in water. On the product side of the reaction, we would show those guys broken up. So they're going to end up being spectators in the course of this reaction. Now, silver iodide, on the other hand, is insoluble. It's a solid. So our net ionic equation that we would write, Ag plus and I minus, come together to make AgI. So all of these where you see like lead to nitrate, if you're wondering like where's the nitrate, or potassium phosphate, where'd the potassium go, right? Nitrates, potassium, they're going to be spectator ions. They end up being canceled out. One like this guy for part D, a solution of ammonium sulfide is added to a solution of magnesium iodide. So ammonium sulfide, ammonium is NH4 +1, and sulfide -2. So if it's ammonium +1, sulfide -2, you would need 2 ammoniums to balance out that sulfide charge. We're going to add to that a solution of magnesium iodide. So if it's a solution, it dissolves. We're going to break it up into ions. magnesium ions, iodide ions. Plus 2 minus 1, you would need 2 iodide ions to balance out that magnesium ion, right? 2 iodide ions. When these guys come together and react, the ammonium is going to go with your iodide, the magnesium with sulfide. If you know your solubility rules, you'll know that anything with ammonium in it is always soluble. So we would show that ammonium iodide as broken up on the product side anyway, so they're going to end up canceling out, leaving just our sulfide and our magnesium ions to come together to form the insoluble product of magnesium sulfide. In that last example there, E, where you take all those ions from your 2 solutions, both barium sulfate and silver chloride